Afternoon. I'm Spot On Weather meteorologist Matthew Euler. Welcome to my latest video. Now, in this video, what I decided to do was look back at some potential analog El Nino winters of the past. Since we're going to be heading into an El Nino winter upcoming here, the 23-24 winter season, I went ahead and looked back at three previous El Nino events and we'll delve deeper into the analysis of those here right now. So starting off with the overview of today's video, I'll take a look at the 2002-2003, not only the winter season analysis, but I will look at the months of October and November. Since we're heading into the latter part of September now, I went back and looked at the fall months, October, November, as well as the winter months. Back in 2002, 2003, 2009, 2010, and then 2015, 2016. All of these years were, in fact, El Nino conditions, had El Nino conditions going on. First, let's start off by taking a look at the sea surface temperature anomalies in the Nino 3.4 region from December 2002 through February 2003. Now, for the sea surface temperature anomalies, I just look solely at the winter months, December, January, and February. I have December of 2002 up here in the upper left. I have January of 2003 upper right. And then I have the bottom here, this is February of 2003. And so the main themes here kind of just shows you how the sea surface temperature anomalies changed over time throughout the winter months of the 02-03 winter season. And so this is one of the first analogs I want to take a look at. And you'll note in December of 2002, there was an El Nino definitely present, as indicated by these yellow and orange colors. You can kind of see what the scale is here on the bottom of each of these graphics. Yellow and orange is above normal water temperatures in that Nino 3.4 region. And whenever you see the blue coloring, even up here in the North Pacific, that indicates below normal water temperatures. And so in December of 2002, we had the El Nino ongoing, extending from the west coast of South America all the way out past the international dateline. We had an area in December 2002 of below normal water temperatures up in the North Pacific, North Central Pacific, and then up in the Gulf of Alaska, there was an area of above normal sea surface temperature anomalies. We shift over to January 2003, and we see that a lot more of the above normal water temperatures are now in the Central Pacific, Equatorial Pacific area. We still see this distinct area of -1°C below normal water temperatures in this blue shading across the North Central Pacific. And look at over here, closer to home in January 2003, along the Gulf of Mexico, as well as off the east coast of the United States, there were below normal water temperatures in that month. February 2003, we start to see that El Nino is really starting to dissipate. Look at the signature in December 02 versus February 03, and you really don't see that stretching out of those above normal water temperatures now. You'd still have a little bit of remnant El Nino left over in February 2003 across the central equatorial Pacific on the order of 0.5 to 1 degree Celsius in the weak El Nino category. Over in the North Central Pacific, we also see in February 2003 below normal water temperatures, and then up along the west coast of Canada into the Gulf of Alaska, we still see above normal water temperatures. And we see the continuation in February 2003 of below normal temperatures there in the Gulf of Mexico, extending up the east coast of the United States. Bottom line here is the December 02 to February 03, that particular time frame as far as sea surface temperature anomalies, we had a centrally based El Nino. The warmest waters were out over the central portions of the equatorial Pacific, and it was a moderate El Nino winter. 1.3 degrees Celsius above normal was the peak. And again, the re-emphasis on the above normal sea surface temperatures up here in the Gulf of Alaska. If we look at December 2009 to February 2010, those sea surface temperature anomalies, in December 2009, here in the upper left, we see a very distinct area of above normal waters extending from the eastern equatorial Pacific to the central equatorial Pacific area. You will note here in December 2009, the most above normal, the greatest above normal water temperatures were over the central equatorial Pacific. And there was another area of well below normal waters in the Gulf of Alaska, right on down the west coast of Canada, and right on into the north central Pacific. Over here on the right, upper right, we have January 2010 sea surface temperature anomalies, and it's a very distinct and very clear central-based El Nino in this particular winter season, the 09-2010 winter season. Look at where the warmest water temperatures are located across the central equatorial areas. And you really had, neutral conditions as far as water temperatures, not above nor below normal over the west coast of Canada, right on down to the west coast of the United States. We still did see a little bit of a patch of below normal water temperatures across the north central Pacific in January 2010. And then look at this again, right off the east coast of the United States across the North Atlantic. We saw this blue shading indicative of below normal water temperatures. Bottom here showing the sea surface temperature anomalies in February 2010. We still see that El Nino, it's a fairly strong one. And back in 2010, peaking at a temperature of 1.6 degrees Celsius above normal in the Nino 3.4 region. But working our way westward here, closer to the date line, along the equator, we have the warmest sea surface temperature anomalies indicating that central-based El Nino. You will notice along the west coast of the United States, again in February 2010, there's really no particular phase favored for the Pacific Decadal Oscillation in that particular month. Looking at December 2015 to February 2016 winter season, the sea surface temperature anomalies, distinctly very strong, well above normal water temperatures, very distinct from the west coast of South America, extending westward to the central equatorial Pacific area. And we had a positive PDO, very strongly positive PDO here as well. You see the above normal water temperatures along the west coast of the Canada area, down off the west coast of North America, and the United States in particular. And we had above normal waters actually this time in December 2015 in the Gulf of Mexico, right up the east coast of the United States. Over here on the right, the sea surface temperature anomalies in January 2016, showing the just in excess of 2.5 degrees Celsius. In fact, this El Nino, the 15-16, El Nino peaked at 2.6 degrees Celsius above normal. Just impressive numbers. Along the west coast of the United States, you still have that positive PDO. And then you have slightly below normal water temperatures across the north central Pacific going back to the northwest Pacific. Again, for January 16, very similar to December of 2015, we had above normal water temperatures into the Gulf of Mexico right up the east coast of the United States. And then bottom here showing February 2016 sea surface temperature anomalies. The El Nino, some of the warmest waters associated with El Nino have now shifted further to the west over the central equatorial Pacific area. We still see that indication of a positive Pacific Decadal Oscillation, positive PDO, and then below normal waters generally south of the Aleutian Islands up in the north central Pacific Ocean. So in summary, I kind of summed up this particular winter season. It was mostly an eastern-based El Nino in December. You can see where the warmest waters were in the month of December, generally closer to the coast of South America. And then it transitioned to more of a central-based El Nino by February. And again, it was a very strong El Nino. 2.6 degrees Celsius above normal was the peak water temperature anomaly in that Nino 3.4 region. And the clear signature here is of a positive PDO. We got above normal waters off the west coast of North America. Now let's shift our gears to what was going on in these particular three analog El Nino winters as far as the Quasi-Biennial Oscillation, the QBO. If we look at this chart here, anytime you see the blue shading and the negative values, that's indicative of the negative or easterly phase of the QBO. Whenever you see these maroon colorings, this is indicative of the positive or westerly phase of the QBO. So we look back at the 2002-2003 winter season, we basically had a slightly negative QBO. By the way, the last column here is, these are broken out by month. So the far left column here is January, going all the way over to the far right column, which is December. So in the December of 2002, we had a minus 0.5 value for QBO. It got a little bit stronger in January and February, going to a negative 1.39 and minus 1.43 values for the negative QBO, and got even stronger in March. So in general, we had a slightly negative QBO for the winter of 2002-2003. Then in the winter of 2009-2010, during that El Nino winter, we had a strongly negative QBO. This is impressive values here. December minus 15.57, January minus 16.02, February minus 16.98, and then look at March minus 19.68. So we had a negative phase, easterly phase, the QBO in the winter of 2009-2010. And then finally, the 2015-16 winter season, the third analog El Nino winter we looked at, we generally had a strongly positive QBO. So we had a value of positive 11.39 in December, positive 9.34 in January, and positive 6.77 in February. And I'll get into the importance of the QBO here momentarily. As far as the Pacific Decadal Oscillation, the PDO, here's a graphic courtesy of NOAA, just a summation of the three winters that we're looking at in this video. 2002-2003 winter featured a neutral PDO. If you look over here, in that era of 2002-2003, we're looking at generally a neutral PDO. It transitioned from a negative PDO to a positive PDO, but it was kind of in that transition zone in the winter of 2002-2003. In the 2009-2010 winter season, we had a negative PDO setting up. See the blue bars here, the negative value side of things. And then the 2015-2016, that particular winter season had a positive PDO. Look at these bars, these red vertical bars above in the positive territory, above the zero line. Just as a reminder with PDO phases, why do we look at the PDO? Generally because if we have a positive phase of the PDO in the northern hemisphere, this generally shows you, the blue coloring shows you where temperatures are typically more likely to experience below normal levels. So below normal temperatures in the blue coloring, and then above normal water temperatures with a positive PDO off the U.S. West Coast, as well as extending into the northern plains, Montana, and the Dakotas. Alaska with a positive phase PDO, you're very, very warm, by the way. And negative phase of the PDO, on the other hand, you see where the colder than normal temperatures occur in the winter season, generally concentrated across the Ohio Valley. But we do see some of the warmer values come up the coast from Florida, Georgia, the Carolinas to Virginia in a negative phase PDO winter. We also see above normal, higher probability of above normal temperatures across West Texas, New Mexico, eastern Colorado, and western Kansas, with additional below normal readings across the northern plain states, the northern U.S. during a negative phase of the PDO in winter. In Alaska, it's outside of the coastal areas, the southern coastal areas of Alaska. It's a different story when you have a negative phase of the PDO. You generally have colder than normal temps for the winter season. Now let's turn our attention to the PNA and what it looked like in our three El Nino analog winters. Strongly positive phases of the PNA actually occurred in all three of these winter seasons. You can look here at the graphic here, 2002-2003. The end of 2002 and 2003, early in that period, you see a major spike here into the positive territory, the red coloring, indicating positive PNA. If we look at 2009-2010 a little bit more in depth, late 09 into early 2010, again, we have these red little peaks, this red coloring, these peaks for those particular months, the winter season of 2009-2010, indicating that positive PNA. And then in 2015-16 winter season, we had it again. Look at the end of 2015 into December, and then January, February, we had a strongly positive PNA. If we look at the archive from the Bureau of Meteorology there in Australia, from their website, we looked at the MJO, the Madden Julian oscillation for the winter of 2002-2003. Over here on the left is a graphic, the MJO phase diagram for the months of October through December 2002. My main focus over here on the left is for the December time period, which is indicated in the blue color. This blue line represents the month of December. We look over here on the right side, we have the MJO phase diagram archive, what it looked like from 1 January 2003 to 31 March 2003. And I'm paying attention really to the months of January and February here, and they were kind of in this small inner circle in that winter of 02-03, indicating the MJO had very little influence in those particular months on the U.S. weather. I will say, though, getting back to this diagram on the left, you look at this blue line for the month of December, starting off here at the 1st, started in phase 6, but worked its way into phase 7, but more importantly, working its way into the colder phases of MJO phase 8 over here, and even came back out into more amplified territory into a colder phase 1 in the month of December 2002. So just as a rehash or refresher for everybody, generally December, January, and February, if you're in phases 8, 1, and 2, you're in a colder regime as far as temperatures for the eastern U.S. If you are in phases 4, 5, and 6, the MJO phase diagram, you're generally expecting warmer than normal temperatures in the eastern U.S. during the winter months. Let's move ahead now to the 2009-2010 winter season MJO. Again, paying attention to the blue line over here on the graphic on the left for December 2009, and you can see where it's heading. Generally, it is moving by the end of December. It's working its way into the colder MJO phases of December 2009 into phase 8 and 1, and even over to 2. On the right, this is from January 2010 to March 2010, and really pay attention to, let's see, January, and this one is this diagram. January is the red line. So January, you were kind of over on this side of the MJO phase diagram, closer to the smaller inner circle. So not quite amplified very much. It got more amplified in January towards the end of the month into phase 7. And then look at February, though, how the MJO rotated into phase 8. And it's fairly strong over here, this green line, into a colder phase in February of 2010. Looking at the 2015-16 MJO, over here on the left again, the blue line is what I'm interested in. That's the month of December. And you'll notice in December 2015, wow, the MJO went into a stronger, warmer phases of 4, 5, and 6. Look at this. On this side of that MJO diagram, you're in the warmer territory for eastern U.S. temps. So it's no wonder December saw such a warmer than normal period based on this alone. We look over here on the right, this is for January 2016 to March 2016. I'm really focusing on the red line here. This is January, and look what happens in January. You start in phase 7, and then the MJO rotated into a colder phase 8 and 1 and 2 in January of 2016. Now this El Nino winter, you're working your way into MJO colder phases, and there was a major mid-Atlantic snowstorm in January 2016 that buried a lot of folks in the mid-Atlantic, interior mid-Atlantic. Portions of Virginia, for example, got buried under 2 feet of snow. So there was a major nor'easter that occurred during January in 2016. I can't remember the day right now as a notable event. I think it was towards the middle of the month, like 15, 16 January. I could be wrong on that, but I know there was a massive winter storm in this particular very strong El Nino winter, but the MJO played a role here by going into colder phases in that particular month in January 2016. February went a little bit milder again. See the green line here? It's rotated from the colder phases in January. The blue line is, no wait, the green line is February. So we went from colder phases in January 2016 to warmer phases in February 2016. And then this blue line represents March. Let's take a look now at the stratospheric polar vortex. What I like to look at is the strength of the vortex. So 2002, 2003, by the way, these 3 graphics I'm about to show you, the next 3 slides, were plots conducted by Tomer Berg. So I definitely wanted to give him credit for these. Okay, so we're looking at, so what are we looking at here on this diagram? Okay, first of all, this black line, it represents the 2002-2003 particular the zonal mean zonal winds. And whenever this area, this dark black line here in this case, whenever it's in positive territory, that indicates that we have a stronger polar vortex. Now, the higher this goes, the higher this black solid dark line gets, the stronger the polar vortex in the stratosphere, and also this is an indicator of a mild mid-latitude situation rather. Whenever you see these strong positive wind values. Now, if this black line were to dip below this zero line, that's going into negative territory. That means the winds are reversing direction and slowing down in speed. And that could be an indicator of a weaker stratospheric polar vortex and a sudden stratospheric warming event. So in this particular winter season, 0203, in December, we had a fairly strong stratospheric polar vortex. That means all the coldest air would typically remain bottled up in the Arctic area, and the mid-latitudes would be milder. And then you see this major drop-off here in late January. See this black line, how it dips? It goes temporarily into the negative values. So that means our winds are shifting direction in the stratosphere. And this is indicative of a sudden stratospheric warming event and a weakening stratospheric polar vortex. And then it was even stronger. We see a stronger dip in the wind's velocities to the negative side here. But this was into early April. The 2009-2010 stratospheric polar vortex, let's take a look at the zonal mean zonal winds at 10 hectopascals or 60 degrees north latitude. So in December of 2009, we saw a little bit of a weakening in late November, but then in December it climbed again. The winds in the stratosphere increased, reaching quite a high peak here in late December of 2009. Look how high this black line gets right up in this location. And then look at this major crash, this major drop-off of these mean zonal winds at 10 hectopascals or 10 millibars, way high up in the stratosphere. And so this is indicative of a weakening stratospheric polar vortex, and it even dips into negative values briefly there at the end of January before recovering a bit but then dropping down again. So this is indicative of a weaker stratospheric polar vortex in the particular time frame of late January. This was a significant drop-off actually in January 2010. Moving on to the 2015-2016 stratospheric polar vortex, look how high this value got now. Whoa! Strongly on the positive values as far as the winds go in meters per second here. This is indicative of a very strong stratospheric polar vortex up here. Wind velocities 70 meters per second plus. In early January in 2016, January 2016. But really, look how it climbs up and gets stronger, the stratospheric polar vortex, how these winds increase on the positive side of things. So there was a very strong stratospheric polar vortex into early January, and then there was a little bit of a weakening here, pretty significant weakening actually, around mid-January. And then you see an increase again in strength there in early February before it was a major drop-off at the end of February and beginning of March, right in this zone here. So in general, that kind of sums up the 2015-16 stratospheric polar vortex strength based on these winds at 10 hectopascals, well above the Earth's surface, high up into the stratosphere. What about the Arctic oscillation in the respective 3 analog El Nino winters? Okay, so in late 2002, we had a strongly negative AO, and you can kind of see that right here. See the blue bar here. These blue dips, blue coloring, blue shading indicate a negative value of the AO. And whenever you see the red shadings above the zero line, that's a positive value of the AO. So it was strongly negative AO in late 2002 right here, but then there was a recovery in early 2003. As far as 2010 winter season, this was impressive. You go to the end of 2009 and look how sharply downward this blue coloring is. That's indicative of a strongly negative Arctic oscillation. And then it just continued, okay, right into early 2010. And then there was another major drop-off in the Arctic oscillation to the negative side at the end of 2010. In fact, this one drop-off at the end of 2010, this major strongly negative AO occurred. We had a major snowstorm for Southeast Virginia when this thing was this negative in late 2010. Where we had a major snowstorm. It started snowing on Christmas night 2010 and dumped over a foot of snow on the Hampton Roads, Virginia cities. And then we look at the late December 2015 and early January 2016 time period. Look at this. It's a strongly positive AO. Right, so strongly positive AO ties in nicely with how strong the stratospheric polar vortex was. So all the cold air was locked up to the Arctic, and it was milder in our part of the world in the eastern U.S. So really interesting. Okay, so that kind of summarizes things for the AO. Now the NAO, North Atlantic Oscillation, it featured a strongly negative NAO in December 2002. So right here, late 2002, see this major drop off, that blue shading here, major drop off to the negative side for the NAO. That negative NAO is indicative of North Atlantic blocking or upper level ridging, which typically you get a negative NAO signature that's going to be associated with colder temperatures in the eastern US. And then as you look into early 2003, things recovered a bit to the positive territory. As far as the winter of 2009-2010, let's go back over here, late 2009-2010. Look how strongly negative the NAO was. There was a lot of high latitude blocking or ridging into the North Atlantic. I mean, look at this. Late 2009, major crash into the NAO, and then all of 2010, it's pretty much negative NAO the whole entire year. That's impressive. And then the 2015-2016 winter season, let's take a look and examine that. We had a positive phase, the NAO, okay? And then we had that lasting from December 2015 right on into the early parts of 2016. Look at this, the red shading. So a lot of the indicators, when we look at teleconnections, were favoring those milder temperatures, which we saw in the winter of 2015-16 across the eastern U.S. Now, let's do some comparisons of the winters. I'm going to do a temperature and precip anomaly comparison. And now I am going to include the fall months of October and November in these comparisons, as well as the months of December, January, and February. So this was 2002 temperature anomalies in October, showing milder than normal temperatures in the orange coloring, and green and purple are colder than normal values. Blue is colder than normal as well. So you see just this one area of the southeastern U.S. up to the mid-Atlantic was warmer than normal when it came to October 2002. And then over here on the right, 2009, almost the whole United States was below normal, with the strongest or highest degree of below normal readings across the Rocky Mountains of Wyoming, right here into parts of South Dakota, Nebraska, eastern Colorado. If we look at the temperature anomalies for October 2015, on the other hand, we had slightly below normal temperatures extending down from Maine all the way down to the mid-Atlantic, and it was well above normal across the Pacific Northwest in October of 2015. Looking at the precip anomaly comparisons, this is 2002, October 2002 on the left, green indicating above normal precip, brown below normal or dry conditions. So October of 2002 was quite wet across the Gulf Coast, Texas, Louisiana, as well as Mississippi, Alabama, into the Florida Panhandle up to the mid-Atlantic. Over here on the right shows October 2009 precip anomaly comparisons, and look how wet it was across the southern U.S., specifically eastern Texas, Louisiana, Arkansas, up to Missouri and Illinois. It was drier than normal right here into the Hampton Roads, Virginia cities, as well as right along the east coast of North Carolina, as well as Florida, and the desert Southwest was pretty dry. Meanwhile, coastal California and central portions specifically had above normal precip in October 2009. Looking at October 2015, now we have above normal precipitation across the Carolinas on up towards Virginia. We had also above normal precip from southern Mississippi, Louisiana, Texas, New Mexico, Arizona, southern California, into parts of Nevada. We also had dry conditions in October 2015 across the Midwest and Florida, as well as the immediate west coast from Oregon down to northern and central California. Looking at the November temperature anomaly comparisons now, this was November 2002. Look how below normal conditions were east of the Rocky Mountains to the east coast. And then we got to November 2009, and it was like a whole different story. We had well above normal temperature readings across the northern plain states on the order of 7 to 9 degrees Fahrenheit above normal. But most of the U.S. is in this orange coloring indicating above normal temperatures in November 2009. Just a couple cool areas along the Gulf Coast and also along the immediate west coast of the United States. And then this was the November 2015 temperature anomaly. Look how above normal things were east of the Rocky Mountains in 2015. It was almost like the fall predicted the winter here as far as the temperatures and how mild. It was a foreshadowing thing here. Again, let's go back here. I want to look at this one more time. So, okay, so this was October of 2015, just slightly cooler than normal on the East Coast, but a lot of the U.S. is well above normal, okay? And let's go back now to our current comparison. November of 2015. Look at this. I mean, we're well above normal here, east of the Rockies. The only location in November of 2015 that was below normal temperatures was west of the Rockies to the west coast. Let's look at the Precip anomaly comparisons. November of 2002 over here on the left. November 2002, green above normal precip all the way up the eastern seaboard up to New England. Well below normal in precip, dry across the Midwest, the upper Midwest, northern plains, Pacific Northwest. Look how above normal the precip was across Southern California. Things started cranking up in that El Nino year. In November 2009, look how wet it is across the Mid-Atlantic. Well above normal in Virginia and North Carolina. And then well below normal for a lot of other folks across the United States. Look at all these browns all over the U.S. Looking at November 2015 precip anomalies, wet again, Virginia southwestward to the Gulf Coast, very wet in the Midwest, up to the upper Midwest, down to the south central U.S. and the Gulf Coast. Below normal patches across parts of North Dakota, New England, you were below normal in November 2015, and then Southern California was also below normal. Now, moving on to the winter months, December 2002 on the left here, very cold, below normal, generally east of the Mississippi River. Florida, northern Florida, 4 to 5 degrees Fahrenheit below normal. Parts of Pennsylvania, the same. But the blue coloring goes all the way up and down the East Coast. Look where the warmth was in December of 2002. This looks like a very typical El Nino map, what you'd expect in an El Nino. Well, above normal readings across the northern plain states to the Pacific Northwest. By the time we got to December 2009, whoa, what happened here? This was a lot of cold across much of the United States from coast to coast in December 2009. Not much warmth. Look at these readings here in Montana and the Dakotas, eastern Wyoming, down in Nebraska. We're talking 8 to 14 degrees Fahrenheit below normal readings back in December of 2009. Looking at December 2015, this is what blows my mind. You can get a strong El Nino here and be well below normal in December 2009, and then way above normal in December 2015. This is a very strong El Nino winter. And so anywhere east of the Mississippi River, you were wondering where winter was. This brown shading indicates temperatures in the order of 9 as much as 11 degrees Fahrenheit above normal in December of 2015. The only cool spot that month was out in the desert southwest areas as well as California. Here are the precip anomaly comparisons now for December of, we'll start with December 2002 over here on the left, showing a slightly above normal precip across the Mid-Atlantic, but well below normal precip across the central U.S., Nebraska, Iowa, into northern Kansas and northwestern Missouri, well below normal precip across the desert southwest. And then we saw above normal precip around Florida. We saw above normal precip in Texas, Oklahoma, Arkansas, as well as portions of central and northern California up to Oregon, well above normal precip in December of 2002. In December 2009 here on the right, we see well above normal precip. This is a typical El Nino effect here where we get well above normal precip from DC right on down through Virginia, the Carolinas, Georgia, southern Mississippi, Alabama, Florida. And then you get above normal precip also back towards Texas. And then here's your drier than normal conditions across the Pacific Northwest. Typical El Nino effect. In December 2015, look what we had here. We had well above normal precip from northeastern Oklahoma on northeastward towards Missouri into Illinois. Another stripe here of well above normal precip in December 2015 for portions of Wisconsin, Iowa, right on down southwestward into Kansas. And ironically, we had above normal precip across the Pacific Northwest. I say this shouldn't be the case during the El Nino winter. Typically, you see this would be the brown coloring, drier than normal up here, and you'd have wetter than normal conditions, Southern California into New Mexico down here. That's the normal order of things for a El Nino winter. You would have, again, drier than normal Pacific Northwest and Northern Plains, and wetter than normal down here with a more active southern storm track. You will notice in December 2015, it was very mild across the mid-Atlantic, and we are also very wet, well above normal precip. Now let's look at the January temperature comparisons. This is January 2003 on the left, showing a very, very cold situation east of the Mississippi River to the east coast in January 2003. And then you go west of the Rocky Mountains, it's a different story. Well above normal temperatures in January 2003. As far as January 2010 here on the right, showing above normal temperatures above normal temperatures across the Pacific Northwest, and then well below readings again in January 2010 across the Midwest, extending southeastward to the Gulf Coast up to the Mid-Atlantic. Looking at January temperature comparison here, this is January 2016. This was really the only chilly month or below normal month for the whole entire winter of the 15-16 winter season. Right here in the eastern U.S. across the Mid-Atlantic, the Ohio Valley, and then also along the Gulf Coast into Texas, slightly below normal into Southern California, Arizona, New Mexico, but above normal up in Maine, above normal in the northern plain states in January 2016. Looking at the precip anomaly comparisons, look how dry things were in January of 2003 across much of the United States, basically indicated by this brown coloring. It was El Nino winter, and look at you in Southern California. You're going, what the world? No, it's not an El Nino winter to us because there's no rain falling. So very dry month for the U.S. as a whole in January 2003. January 2010 here on the right, notice how much above normal things are in this particular January in 2010. Well above normal in Southern California and parts of southern Arizona, New Mexico, and Texas. Also above normal up from the Florida Panhandle upward, northeastward to Virginia. And below normal precip across parts of Michigan down into Illinois, Indiana, Ohio, as well as drier than normal out in Wyoming, Central Plains states, Nebraska, eastern Colorado, and Kansas. Looking at January 2016 precip anomalies, showing wetter than normal conditions across California and Nevada, and then drier than normal again over a large part of the United States. Texas drier than normal, Arkansas, Missouri, Illinois, Indiana, Ohio, right up to New England, drier than normal. Distinctively wetter than normal across Florida in January 2016, central and southern Florida in particular. And then finally, February temperature anomaly comparisons. This is February 2003 on the left. And look at, we're still remaining below normal green shading here for the temperatures for a large portion of the eastern United States, including you in New England, down to the Texas area, below normal. A lot of blues and greens on the map in February 2003. The only above normal spots were southern Florida and also up here into Washington State. February 2010 temperature anomalies on the right. Look at the purple coloring, how much below normal temperatures were in February 2010, Texas all the way to Florida. We're talking 8 to 10 degrees Fahrenheit below normal in February 2010. Well above normal in Maine, and then well above normal in the Pacific Northwest. February 2016, oh, it's a completely different story as compared to February 2010, isn't it? Look at February 2010, February 2016. Look how above normal things were across the northern plains, eastern Montana, the Dakotas, on the order of 10 to 14 degrees Fahrenheit above normal. Maine, again, 4 to 5 degrees Fahrenheit above normal. And then really near average in the Mid-Atlantic, slightly below normal into Florida for February 2016. Looking at the precip anomaly comparisons, February 2003 on the left, wetter than normal conditions across the Mid-Atlantic, wetter than normal conditions across the desert Southwest, into El Paso area of Texas, right on down to South Texas, drier than normal in the upper Midwest, drier than normal in the northern plains, and then drier than normal along the U.S. West Coast, including you in the Pacific Northwest back in February 2003. Over here on the right is February 2010, well above normal precip across the panhandle of Texas, right on into eastern New Mexico, and then also down into the Rio Grande Valley, above normal precip into Florida back in February 2010, and slightly above normal in the Mid-Atlantic, definitely up into the coastal sections of New England, New York City, Boston, Hartford, those areas. And then finally, February 2016, Precip Anomalies. Look how dry things are here in Southern California. Let's go back. So slightly above normal in West Texas, near normal in California, Southern California, and then look how dry things got in February 2016 along Southern California, Arizona, New Mexico, into West Texas, drier than normal up to the Midwest as well. The real hot spot, if you want to call it that, for above normal precip was from Maine all the way down to the Mid-Atlantic, right down the East Coast. All right, so let's take a look at the summary of everything we covered. We'll start with the 2002-2003 winter season. I summed up everything we looked at, like all the teleconnections, and put it together in these bullets here, okay? So we're starting with 02-03 winter season. It had a centrally based moderate El Nino, slightly negative QBO. Now, I didn't mention this about the QBO. Whenever we're in an easterly phase of the QBO, that tends to lead to colder than normal temperatures for the eastern U.S. Whenever we're in a westerly phase of the QBO, positive or westerly phase of the QBO, we tend to have milder than normal temperatures across the eastern U.S. So that's the importance of this QBO factor. I look at that in developing the winter forecast. So 02-03 winter season, again, in summary, centrally based, moderate El Nino, slightly negative QBO, had a neutral PDO, strongly positive PNA, colder phase of the MJO in the early part of winter in December before transitioning to a weakening MJO impact in January and February. Additionally, 02-03 winter season had a strong stratospheric polar vortex, that's the SPV, stratospheric polar vortex in December. It was very strong before transitioning to a weaker stratospheric polar vortex in January and February. And there was a strongly negative AO and NAO in December before transitioning to a positive AO, NAO in January. So this is a summation of the 2002-2003 winter season. We look at the 2009-2010 winter season. It had a centrally based strong El Nino, strongly negative QBO, negative PDO, strongly positive PNA, colder phase of the MJO in December and February. Had a very strong stratospheric polar vortex in late December before transitioning to a weaker stratospheric polar vortex in late January and February. So the stratospheric polar vortex weakened later in the winter and had a strongly negative AO and NAO, very strongly negative. Let's look at the 2015-16 winter season. It had an eastern-based El Nino in December, transitioning to a central-based El Nino later in the winter. Also, 15-16 had that very strong El Nino, 2.6 degrees Celsius above normal water temps in Nino 3.4 region, had a strongly positive QBO or westerly phase, positive PDO, strongly positive PNA, colder phase of the MJO in January, and warmer phases of MJO in December and February. Had a very strong stratospheric polar vortex that winter season, and a strongly positive AO and NAO from late December to January. A lot of this favors warmer than normal temps in the east, and it was a very mild winter overall. Eastern-based El Ninos tend to favor milder temperatures in the eastern U.S. in the winter. All right. The central-based El Nino, by the way, tends to favor colder temperatures in the eastern U.S. in the winter. But also that very strong El Nino, okay, that positive phase of the QBO is big. And then positive PDO. Now the positive PDO would be the one thing that would suggest colder than normal temps in the eastern U.S. with troughing, as well as the strongly positive PNA. These two would go for colder temps in the east. But the colder phase would also be the colder phase of the MJO in January would also favor colder temps in the east. But still a very strong stratospheric polar vortex all winter and a strongly positive AO and NAO. That's going to keep all the Arctic air bottled to the north, all the cold air bottled to the north in the Arctic and milder mid-latitudes. So what's ahead? What's ahead? And I'll be examining these factors as I do my winter forecast in October, but just want to talk about a few things here. Okay, so first of all, right now we have an eastern-based El Nino. See where the warmest sea surface temperature anomalies are occurring? Off the west coast of South America, okay? We have a moderate El Nino value right now. We're sitting at positive 1.245 degrees Celsius in that Nino 3.4 region. By the way, these are the classifications of El Ninos based on the sea surface temperature anomalies in the Nino 3.4 region, ranging from weak going all the way to very strong. This is your Nino 3.4 region right here. See this right here? This is Nino 3.4 region. This is the latest from IRI, International Research Institute. These are model predictions of the ENSO from September, from just literally released a few days ago. I'm a fan of going in between. My forecast is going in between the dynamical models as well as the statistical models. So between the dynamical and statistical models is where I'm leaning for this upcoming winter. As far as these sea surface temperature anomalies go for that 3.4 region. So I'm thinking we're going to be sitting in strong El Nino territory, but then it will start weakening into moderate range El Nino territory. I don't believe we're going to be as warm as what's indicated here in the maroon line or as weak as what's located here in the blue line, but I think we'll be right in between those two lines. That's just my opinion. We're also forecasting an easterly or negative phase QBO for the upcoming winter season. This is the Singapore radio sound observation from yesterday, the 22nd of September, showing anytime the blue line is to the left. So this is the line right here, the levels in the atmosphere. Whenever this blue line is over here in negative territory, that indicates the easterly phase of the QBO. Okay, the negative or easterly phase is when you see these values to the left in negative territory. So we're looking at a easterly or negative QBO upcoming in this upcoming winter season. Why is that important? I mentioned about favoring colder than normal temps in the east with the easterly QBO or negative QBO. But also, research has shown it favors more frequent sudden stratospheric warming events and a weakened polar vortex in the stratosphere. So that's why I focus in on this. All right, that wraps things up. By the way, I wanted to put out that I'm going to start doing my weekly teleconnection discussion videos very soon, coming in October, and then also the winter forecast videos coming up in October. It's always a challenge to forecast a winter forecast, but you know, I give it my best, okay? As far as the weekly teleconnections videos, I'm going to cover all the major teleconnections or drivers. We'll take a look at that every week and see how things change over time throughout the upcoming fall and winter season. By the way, happy fall. It is the first day of fall today, 23rd of September. So happy fall to everyone out there. I appreciate everybody's subscription to the Spot on Weather YouTube channel, and I look forward to producing some more great informative videos to come. So, you know my saying at the end, until next time, take care and God bless everyone.